Now in this lesson we are going to discuss linearization. So as an example, let's take the function y equals tangent x, okay, and look at a graph of this function. So here is a graph of this function in an open interval that is contained between -pi/2 to pi/2, okay. Now let's look at the function near 0. Here it looks locally it looks a little bit like a straight line. So the best way to approximate that with a straight line is to look at the tangent line to this graph, okay, at 0, 0. So we have y equals tangent x. So what is the derivative of tangent x? The derivative is secant square x, right? And if we compute the value of secant square x at x equals 0, you know that's, oops, sorry about that. You know it's going to be how much? It's going to be simply 1. I did it rather very long way, but anyways, so we have the derivative at x equals 0 as secant square of 0, which is simply how much? 1. So equation of the tangent line at 0, 0 would be what? Y minus 0 equals slope times x. Slope is 1. Slope times x minus 0, which is x. So that will be simply y over x. So let's bring this graph down here and see how well, how nicely does y equals x approximate this graph near 0. Let's change colors a little bit. So say we got here. So in the vicinity of 0, 0, you can see the graph of tangent x is well approximated by the graph of who? Y equals x, okay? And by the time we get past like x equals 0.5, yes, it starts to like go away a little bit. So we may do this. We know pi is a transcendental number, but it's still, we are quite familiar with pi. Okay, so let's look at pi over 4, which is going to be between 0.7 and 0.8, and just do the same thing here. That is, look at equation of tangent line at pi over 4 instead of 0, and see if we can get another straight line that can approximate this graph in this area. Okay, so what that will be secant square pi over 4. Okay, and remember cosine of pi over 4 is the square root of 2 over 2. So we'll expect it to be how much? 2, and it indeed is 2. Okay, so if we write equation of the tangent line at x equals pi over 4 and tangent of pi over 4 is 1, so we will get the equation as y minus 1 equals how much? 2 times x minus pi over 4. Okay, now we will see if that does a good job in this area then. Okay, so let me go ahead and bring that in here for you. So we got who? 2 times x minus pi over 4. Okay, and then we got what? We got a 1. We had a red before. We might give this a blue. All right, so here you can see in this area it's being approximated by this blue line, and of course this one did the approximation pretty good on both the sides of x-axis, but this one is doing it only, very well here. And just very quickly, let me just show you an upcoming attraction. That is when we do the infinite series. At that time we will be able to make power series approximations. So yeah, let's go with a number of terms 5 for this series in the powers of x, say. So let's see what happens in case we bring this one in here. Okay, that is, let me remove this. We are not going that far yet. So here we are approximating tangent x with what? With this polynomial of degree 5. All right. And again, this is not a part of this course. Later on, when we do infinite series, that's when we are going to take it up. And just want to show you a payoff of this. So I'm just choosing a color. Let's choose purple. Okay, and you can see this here, that it's doing a good job, you know, as compared to the blue and red together. We can see that again. So here, let's delete this guy, and you can see that this polynomial of degree 5 is approximating this tangent x pretty well in between these two values of x. But let's go back to our main point, that is linearization. That is what we are using in this course.